You're floating in the cold darkness of space, your heart pounding as you drift closer to something that shouldn't exist. Something so impossible, so mind-bending, that it breaks every rule of reality you thought you knew. The stars around you begin to stretch and warp like melted glass. Time itself starts to slow down, and ahead of you lies a perfect sphere of absolute nothingness, a black hole. But here's the crazy part. You're about to find out what happens when you fall inside. Hey everyone, and welcome back to the channel. Before we dive into this mind-blowing journey, I want to know, where are you watching this from right now? Are you in your bedroom at 2 a.m. like I was when I first got obsessed with this topic? Are you on your lunch break trying to wrap your head around the universe? Drop a comment below and let me know what time it is where you are and what got you curious about black holes. I read every single comment, and I love hearing from you. Now, what I'm about to tell you today will completely change how you think about space, time, and reality itself. We're going to take a journey that no human has ever taken, and hopefully never will. We're going to fall into a black hole, and I'm going to show you exactly what happens step by step. And trust me, it's not what you think. You see, most people imagine black holes as these cosmic vacuum cleaners, sucking up everything around them. But that's not even close to the truth. The reality is so much weirder, so much more beautiful, and so much more terrifying than anything Hollywood has ever shown you. Let me start with something that's gonna blow your mind right off the bat. Did you know that if you watch someone fall into a black hole, you would never actually see them go in? Never. You could watch for billions of years, and that person would just freeze, right there at the edge. But from their perspective, they'd fall right through in seconds, experiencing things that would make your wildest dreams look boring. This is just the beginning. By the end of this video, you'll understand why black holes might be the key to understanding everything, from how the universe began to whether we're living in a simulation. You'll know why some scientists think black holes are actually doorways to other universes, and why others believe they might be the birthplace of consciousness itself. But first, let me tell you a story that happened just 3 years ago that changed everything we thought we knew about these cosmic monsters. It was April 10th, 2019. Scientists around the world were holding their breath. For years, they'd been trying to do something impossible: take a picture of a black hole. Not an artist's impression, not a computer simulation, but an actual photograph of one of the most mysterious objects in the universe. The problem was, black holes don't let light escape. So how do you photograph something that's literally invisible? It's like trying to take a picture of a shadow in a room with no lights. The answer required 8 telescopes spread across the entire planet, working together like one massive eye the size of Earth itself. And when that image finally appeared on screens around the world, it was breathtaking. A perfect ring of fire surrounding a sphere of absolute darkness. The Event Horizon Telescope had just shown us the shadow of a supermassive black hole, 55 million light-years away in a galaxy called MADI 7. It was 6.5 billion times heavier than our Sun, and it was spinning at nearly the speed of light. But here's what really gets me excited. That image wasn't just a pretty picture. It was proof that Albert Einstein was right about something so crazy, so impossible sounding, that even he didn't believe it at first. It was proof that space and time can be bent, twisted, and even broken. Think about that for a second. The image you're looking at right now on your screen traveled for 55 million years through the vacuum of space just to reach your eyes. When that light first started its journey toward Earth, there were no humans, no cities, no civilization, just dinosaurs roaming a very different planet. And now, here you are, looking at the edge of eternity itself. But that's just the warm-up. Because what we're about to explore together is what happens when you cross that edge. When you fall past the point of no return and enter a realm where physics breaks down, where time stops making sense, and where the very fabric of reality starts to unravel. Are you ready? Because once we start this journey, there's no going back. Just like crossing the event horizon of a black hole itself. Let's begin with something that's going to sound absolutely insane, but stick with me because it's completely true. If you were to fall into a black hole right now, you would experience the most extreme time dilation in the universe. From your perspective, you'd fall in normally, but to someone watching you from a safe distance, you would slow down more and more as you approached the event horizon until you appeared to freeze completely. Not only that, but your image would get redder and redder as gravity stretched the light waves coming from your body. Eventually, you'd fade away into infrared radiation, then radio waves, then nothing at all. You'd become a ghost frozen in time at the edge of forever. But here's where it gets really weird. While you're frozen in time from the outside observer's perspective, from your own perspective, you'd be falling normally. You'd cross the event horizon in seconds or minutes, depending on the size of the black hole. Time would feel completely normal to you. You'd be living in a different reality than the rest of the universe. This isn't science fiction. This is what Einstein's equations tell us happens when gravity becomes strong enough to warp space and time itself. And it gets even stranger. As you fall deeper into the black hole, something called tidal forces would start to affect you. Now, you've probably heard of tidal forces before. They're what cause the ocean tides on Earth. The moon's gravity pulls on the water closest to it slightly more than the water on the far side of the planet. But inside a black hole, these forces become extreme. Your feet would be closer to the center of the black hole than your head, which means they'd experience stronger gravity. This would stretch you vertically and squeeze you horizontally. Scientists have a darkly humorous name for this process: spaghettification. You'd be stretched into a long, thin shape like a piece of spaghetti. But wait, it gets even more mind-bending. For smaller black holes, the kind that form when massive stars collapse, this spaghettification would happen before you even crossed the event horizon. You'd be torn apart by tidal forces while still technically outside the black hole. But for supermassive black holes like the one we photographed in May 7, something incredible happens. The event horizon is so far from the center that tidal forces are actually quite gentle as you cross it. You could potentially survive crossing the event horizon and live for minutes or even hours inside the black hole before the tidal forces finally became too much. You'd be the first human to see the inside of a black hole, to witness the breakdown of reality itself. And what would you see? This is where things get absolutely wild. As you fall deeper, the curvature of space-time becomes so extreme that light can actually orbit around the black hole. You'd see the entire outside universe compressed into a shrinking circle above you. Stars would appear to move in impossible ways. You might even see multiple images of the same star as light takes different curved paths around the black hole to reach your eyes. But here's the part that really keeps me up at night thinking about it. Some theories suggest that inside the event horizon, cause and effect might break down completely. The normal flow of time might become so distorted that effects could happen before their causes. You might experience your own future before your present. Reality itself might become optional. Now, I know what you're thinking. This all sounds terrifying. And you're right, it is. But it's also beautiful in a way that's hard to describe. Black holes represent the ultimate extreme of nature, the place where the laws of physics are pushed to their absolute limits. They're laboratories where the universe experiments with the impossible. And here's something that might surprise you. Black holes aren't just destroyers. They're creators too. Some scientists believe that black holes might be the engines that power the formation of galaxies. The supermassive black holes at the centers of galaxies don't just sit there passively. They actively shape the cosmic structures around them. When matter falls into a black hole, it doesn't just disappear. It forms what's called an accretion disk, a swirling maelstrom of superheated matter that can outshine entire galaxies. These accretion disks shoot out jets of particles at nearly the speed of light, stretching for thousands of light years into space. These jets can trigger star formation in distant regions of the galaxy. In other words, black holes are gardeners of the cosmos, pruning and shaping the universe around them. They're not just cosmic vacuum cleaners, they're cosmic sculptors. But we're just getting started, because what I'm about to tell you will challenge everything you think you know about reality itself. It's called the information paradox, and it's one of the biggest mysteries in physics. Here's the problem. According to quantum mechanics, information can never be destroyed. If you burn a book, the information in that book still exists. It's just been scattered into the smoke and ash and heat. You could theoretically reconstruct the book if you could track every single particle. But black holes seem to destroy information completely. When something falls into a black hole, that information appears to be lost forever. This creates a paradox that has puzzled physicists for decades. How can information be both indestructible and destroyed? Some scientists think the answer lies in something called the holographic principle. This theory suggests that all the information about what falls into a black hole is actually encoded on its surface, the event horizon. It's like a cosmic hard drive, storing information in 2 dimensions about 3-dimensional objects. But here's where it gets really weird. If this is true, then the 3-dimensional reality we experience might just be a projection of information stored on a 2-dimensional surface. In other words, we might be living in a hologram. Think about that for a moment. Everything you see, everything you touch, every memory you have, it might all be just information projected from a distant surface. Reality might be far stranger and more beautiful than we ever imagined. This brings us to one of the most mind-blowing ideas in modern physics, the idea that our entire universe might have been born from the inside of a black hole. Some theories suggest that when matter collapses to form a black hole, it doesn't just create a singularity, it creates a new universe on the other side. Imagine if every black hole in our universe contains an entire cosmos, complete with stars, planets, and maybe even life. And imagine if our own universe is actually the interior of a black hole in some larger parent universe. It's like cosmic nesting dolls, with universes inside universes inside universes. This isn't just wild speculation. There are serious mathematical models that suggest this could be true. Models that explain why our universe appears to be expanding, why it has the properties it does, and why the laws of physics work the way they do. But let's bring this back to you, falling through the event horizon of our black hole. As you continue to fall, you'd eventually reach the center, the singularity. This is the point where our current understanding of physics completely breaks down. It's a place where density becomes infinite, where space and time cease to have meaning, where the very concept of place becomes meaningless. What happens at the singularity? Nobody knows. It might be a point of infinite density where all the laws of physics break down. It might be a gateway to another universe. It might be the birthplace of new realities. Or it might be something so strange that our human minds can't even conceive of it. Some theories suggest that the singularity doesn't actually exist, that something called quantum effects prevent matter from collapsing to a true point. Instead, it might bounce back, creating what's called a big bounce that gives birth to a new universe. If this is true, then black holes might be the wombs of creation itself. Others think that the singularity is where consciousness and reality intersect in ways we don't understand. There are theories that suggest consciousness might be a fundamental property of the universe, and that black holes might be places where this consciousness becomes concentrated and amplified. I know this sounds like science fiction, but remember, a century ago, the idea of black holes themselves sounded like science fiction. The idea that space and time could be curved seemed impossible. The idea that matter could be converted into pure energy seemed like magic. And yet here we are, living in a universe where all of these impossible things are not just real, but fundamental to how reality works. As you fall deeper into the black hole, time itself would become increasingly meaningless. Near the singularity, the normal flow of time might break down completely. You might experience all moments simultaneously, or you might experience the birth and death of the universe in a single instant. You might become one with the fundamental structure of reality itself. And here's something that gives me chills every time I think about it. If the holographic principle is correct, then the information that makes up you, your memories, your thoughts, your entire identity, would be encoded on the event horizon of the black hole. You'd become part of the black hole's surface, existing in a flattened, two-dimensional form that somehow contains all the complexity of your three-dimensional existence. In a sense, you'd achieve a kind of immortality. You'd become part of the black hole itself, your information preserved forever on its surface. And if someone in the distant future could decode that information, they might be able to reconstruct you exactly as you were at the moment you fell in. But here's the really mind-blowing part. According to some interpretations of quantum mechanics, this process might work both ways. The information encoded on the event horizon might be able to influence the outside universe. In other words, the black hole might be able to communicate with the outside world through quantum entanglement. This leads to some wild possibilities. What if black holes are actually conscious entities? What if they're trying to communicate with us through the subtle effects of quantum mechanics? What if the seemingly random fluctuations in the cosmic microwave background radiation are actually messages from the black holes in our universe? I know this sounds crazy, but remember, the universe is under no obligation to make sense to us. We're just one species on one planet, around one star in one galaxy. The universe is vast and strange and wonderful beyond our wildest imagination, and black holes might be the key to understanding it all. As we continue this journey together, I want you to keep an open mind. We're about to explore ideas that challenge everything we think we know about reality. We're going to talk about the possibility that space and time are illusions, that consciousness might be fundamental to the universe, and that black holes might be the engines of creation itself. So buckle up, because this is going to be one wild ride. We're about to dive deeper into the mystery of black holes than anyone has ever gone before. We're going to explore the cutting edge of physics, the frontiers of human knowledge, and the very nature of reality itself. Because here's the thing, we're all in this together. We're all passengers on a small blue planet, hurtling through space around a star that's destined to die, in a galaxy that's heading toward a collision with another galaxy, in a universe that's expanding toward an uncertain future. And the only way we're going to understand any of it is by exploring it together, by asking questions, by pushing the boundaries of what we think we know. So are you ready to continue this journey? Are you ready to fall deeper into the mystery of black holes? Because what comes next is going to change everything you thought you knew about the universe. We're going to explore the latest discoveries, the most cutting-edge theories, and the most mind-bending possibilities that science has to offer. The rabbit hole goes deeper than you can imagine, and we're just getting started. Let's go deeper down that rabbit hole, shall we? We've talked about being frozen in time, being stretched into spaghetti, and living inside a cosmic hologram. But that's just the lobby of this grand, terrifying hotel at the end of the universe. The real mysteries, the ones that make scientists question the very foundations of reality, lie in what happens next. And it all starts with a single, beautiful, and deeply unsettling idea from one of the greatest minds of our time, Stephen Hawking. For the longest time, everyone, including Einstein, believed that black holes were the ultimate prisons. Once something crossed the event horizon, it was gone forever, trapped for all eternity. The black hole was a perfect, eternal black. But Hawking, with his incredible intuition, realized something was wrong with this picture. He felt that nature shouldn't have such perfect prisons. There had to be a way out, even if it was a strange one. He looked at the strange world of quantum mechanics, the physics of the very, very small, and he found a secret. A secret that black holes had been keeping for billions of years. He discovered that black holes are not completely black. They glow. Now, it's not a glow you could see with your eyes. It's a faint, almost imperceptible whisper of energy, a slow leak from the heart of the abyss. This is called Hawking radiation. And how it works is pure quantum magic. Imagine the vacuum of space, that empty darkness we talked about. It's not truly empty. It's a bubbling, seething foam of what we call virtual particles. For tiny, tiny fractions of a second, a particle and its antimatter twin pop into existence out of nothing, and then almost instantly, they find each other and annihilate, disappearing back into the nothingness they came from. This is happening everywhere, all the time, all around you right now. It's the universe's background hum. But something incredible happens right at the edge of a black hole's event horizon. Imagine a pair of these virtual particles popping into existence right on that line of no return. Sometimes, one particle will fall into the black hole, while its twin manages to escape into space. The particle that falls in has negative energy, which sounds impossible, but in the weird world of quantum physics, it's allowed. When the black hole swallows this negative energy particle, its total mass and energy go down by a tiny, tiny amount. The particle that escaped, meanwhile, flies off into space. To an observer far away, it looks like the black hole has just spat out a particle. It looks like it's glowing. Think of it like this. The black hole is taking a tiny, tiny loan of energy from the universe to create these particle pairs at its edge. It pays back that loan by swallowing one of the particles, which reduces its own mass. The other particle is the receipt, flying off as proof that the transaction happened. Over time, with trillions upon trillions of these transactions, the black hole slowly loses mass. It evaporates. It's not a fast process. For a black hole the mass of our sun, it would take longer than the current age of the universe to evaporate completely. For the supermassive ones, it's practically an eternity. But it's not forever. Black holes have a lifespan. They are born from the collapse of stars, and they will one day die, fading away in a final flash of light. Doesn't that just change the whole picture? These cosmic monsters, these symbols of eternal darkness, are actually finite. They have a life story. They're born, they live, and they die. But this beautiful idea creates an even bigger problem. It brings us back to that information paradox we touched on earlier, but now it's even worse. If you throw a book into a black hole, its information is trapped inside. But if the black hole eventually evaporates and disappears, what happens to the information that was in the book? Where did it go? Did the universe just hit the delete button on a piece of reality? This is a full-blown crisis in physics. The laws of quantum mechanics are sacred. They say information can never, ever be lost. The laws of general relativity, which describe black holes, say that nothing can escape the event horizon. You can't have both. One of them has to be wrong, or at least incomplete. It's like an unstoppable force meeting an immovable object, and the battlefield is the edge of a black hole. This battle has led to one of the most terrifying and controversial ideas in all of science. It's called the firewall paradox. Let's go back to our journey. You're falling toward that supermassive black hole. According to Einstein's theory, crossing the event horizon should be completely undramatic. It's just an invisible line in space. You'd float right across without even noticing it at first. A smooth, gentle ride into the abyss. But some physicists, trying to solve the information paradox, came to a different conclusion. They argued that in order to preserve information, the event horizon can't be an empty, peaceful place. It must be a raging wall of high-energy particles. A firewall. Imagine falling towards what you think is an open door, only to be instantly vaporized by an invisible wall of pure energy the moment you try to cross the threshold. This firewall would be the most violent place in the universe, a seething inferno that destroys anything that tries to enter. This theory solves the information paradox in a brutal way. The information of the things falling in doesn't get lost inside the black hole. It gets scrambled and radiated back out from this fiery wall. But it completely violates Einstein's vision of a smooth, curved space-time. So which is it? A gentle fall into another reality, or instant incineration at a wall of fire? Physicists are still fiercely debating this. It's a genuine mystery at the heart of modern science. What do you think? As you're listening to this, drifting off to sleep, which reality feels more plausible to you? A universe with gentle gateways, or one with fiery cosmic guards? Let me know in the comments which side of the paradox you fall on. It's a question that keeps the world's smartest people up at night. But let's assume for a moment that there is no firewall. Let's assume Einstein was right, and you do get to fall through gently. Let's continue our journey past the event horizon and deeper into the belly of the beast. We're headed for the center, the singularity. But what if I told you that not all singularities are the same? The kind we usually imagine, a single point of infinite density, is what you'd find in a perfectly non-spinning black hole. But in the real universe, everything spins. Stars spin, galaxies spin, and when a massive star collapses, its spin gets hugely amplified, just like an ice skater pulling in their arms. So, almost every black hole in the universe should be a spinning black hole, what we call a Kerr black hole. And inside a spinning black hole, the singularity is not a point. It's a ring. Think about that. Not an infinitely small point of destruction, but a ring of infinite density, spinning at an incredible speed. This changes everything. A point singularity is a dead end. Anything that hits it is crushed out of existence. But a ring has a hole in the middle. Suddenly, there's a possibility of a path forward. Suddenly, the singularity isn't an executioner, but a gateway. As you fall towards this ring singularity, space-time gets warped in even more bizarre ways than we've already discussed. You would find that your path is no longer a straight line down. The spinning of the singularity drags the fabric of space-time around with it, like a spinning mixer in a bowl of honey. This effect is called frame dragging. You'd be forced into an orbit around the singularity, whether you wanted to or not. Inside this inner region, space and time do a final, spectacular dance of confusion. The direction towards the singularity might become a moment in time, and time itself might become a direction in space. You could literally see your own past and future laid out before you as physical places you could try to travel to. This is where the laws of cause and effect throw a final wild party before clocking out for good. Here, you could find what are called closed time-like curves. These are paths in space-time that loop back on themselves. A path that, if you followed it, would lead you back to the moment you started. It's the physical foundation for a time machine. This doesn't mean you could pop out of the black hole back in your own past. Remember, the event horizon is still a one-way door. But inside this chaotic region, your own personal timeline could become a loop. You could be trapped, endlessly reliving the moments after you pass through the ring singularity. It's a chilling form of immortality, a personal time loop in the heart of a cosmic monster. But what if you could navigate this chaos? What if you were a super advanced being who could pilot a ship through this swirling vortex of broken reality? What if you aimed your ship perfectly and flew right through the center of that spinning ring? What happens then? According to the mathematics, something truly mind-shattering occurs. You pass through the singularity, you survive, and you emerge somewhere else. You emerge into a place that is mathematically described as a white hole. A white hole is the exact opposite of a black hole. It's a region of space that nothing can enter from the outside. Instead, it spews matter and energy outwards. It's a fountain of creation, a cosmic birth canal. Could it be that every spinning black hole in our universe is a doorway, and on the other side of that spinning ring of a singularity is a white hole, gushing out matter and energy into a brand new baby universe? Could our own Big Bang have been the white hole exit point of a journey through a black hole in a parent universe? The equations allow for it. It's a beautiful, elegant, and cyclical vision of the cosmos. Universes being born from the hearts of black holes in other universes, a never-ending cosmic chain of creation. Imagine that for a second. The most destructive objects in our universe could also be the most creative. They are the seeds of new realities. Our entire existence, every star, every planet, every living thing, could be the result of someone or something, long ago, in another cosmos, falling into a spinning black hole. It makes our own cosmic story feel so much grander, so much more connected to something beyond our own perception. But there's a catch. There's always a catch in physics, isn't there? This beautiful picture of passing through a ring singularity into a new universe is based on a perfect, idealized mathematical solution. In the real, messy universe, things might not be so clean. Many physicists believe that this gateway would be incredibly unstable. The very act of you, the traveler, approaching the ring would cause reality to collapse. The flood of energy and radiation looping through the time-bending regions inside the black hole would become infinitely strong right at the gateway, slamming it shut in your face just as you were about to pass through. It's an idea called cosmic censorship. The universe, it seems, does not like to reveal its ultimate secrets. It abhors a naked singularity, one that you could actually see and pass through. So it censors it, cloaking it behind the chaos of an unstable gateway, forever shielding us from what lies beyond. So we are left with these tantalizing, dreamlike possibilities. A journey that ends either in spaghettification, incineration at a firewall, an endless time loop, or emergence into a brand new universe. Each possibility is more mind-bending than the last. Each one tells us something profound about the nature of space, time, and information. And each one is still just a theory, a story we tell ourselves based on the mathematical clues the universe has given us. The truth is, we don't know what really happens, and that's the most exciting part. It means there are still grand discoveries to be made, there are still secrets to be unlocked. We are living in an age where these aren't just philosophical questions, they are questions we are actively trying to answer with things like the Event Horizon Telescope and gravitational wave detectors. We are the generation that is peering deeper into the darkness than ever before. As we continue, we will explore even stranger ideas. What if black holes have hair? What if the singularity isn't a singularity at all, but something even more bizarre, like a ball of fuzz or a planet-sized tangle of cosmic strings? The universe is not only stranger than we imagine, it is stranger than we can imagine. And the heart of a black hole is where its strangest secrets are kept. Yes, let's continue our descent. The darkness here is not empty. It's filled with possibilities, each one stranger than the last. We left off with the idea that the universe might shield us from the naked truth of the singularity, a concept called cosmic censorship. It's as if the universe has a sense of decency, and a point of infinite density is just too much to show. But this raises a profound question. If the universe hides the singularity, what is it that we are actually seeing when we look at a black hole? What is this object, really? For a long time, the answer was thought to be elegantly simple, summed up by a famous idea called the no-hair theorem. This theorem states that a black hole is the simplest object in the universe. It has no mountains, no valleys, no complex features, no hair. Once it settles down, it can be described by just three properties: its mass, how heavy it is, its spin, how fast it's rotating, and its electric charge. That's it. Two black holes with the same mass, spin, and charge are completely identical, indistinguishable from one another. Think about what this means. You could make a black hole out of collapsing stars, or out of a billion encyclopedias, or a trillion iPhones, and once it forms, there would be no way to tell the difference. All the complexity, all the information, all the unique properties, the hair of what fell in, seems to be completely shaved off, leaving behind a perfectly bald, simple object. This is, again, the information paradox in its most stark form. Where does the story of the encyclopedias go? Where does the design of the iPhones go? The no-hair theorem seems to confirm that the information is simply gone. But what if the hair isn't gone, but is just incredibly subtle? What if it's woven into the very fabric of space-time itself, in a way we've only just started to understand? This is the basis of a groundbreaking new idea called quantum hair. The idea is that when something falls into a black hole, it leaves a tiny, faint imprint on the black hole's gravitational field. It's like dropping a pebble into a perfectly still lake. The lake's surface eventually becomes calm again, but for a while, the ripples carry information about the size and shape of the pebble and where it fell. Quantum hair is the gravitational equivalent of those ripples. The information of what fell in isn't stored inside the event horizon, but is encoded in these subtle quantum gravitational effects outside the event horizon. This means the information is never truly lost to the outside universe. It's still there, whispering its story into the gravitational field for anyone with a sensitive enough instrument to hear. If this theory is correct, it means black holes are not bald at all. They have a rich, complex, but nearly invisible head of quantum hair. It's a beautiful solution. It potentially solves the information paradox without needing a destructive firewall, and it respects both Einstein's theory and the laws of quantum mechanics. It means that the unique story of everything that falls into a black hole is preserved, written in the language of gravity itself. This idea that a black hole is a complex object with a memory leads us to an even more radical and wonderfully strange picture of what a black hole might be. This idea comes from a branch of physics called string theory, the theory that suggests that at the most fundamental level, everything in the universe isn't a point-like particle, but a tiny, vibrating filament of energistring. And in string theory, a black hole might not be a point of infinite density at all. Instead, it might be something called a fuzzball. Forget the idea of an empty void leading to a singularity. Instead, imagine that as a star collapses, the matter doesn't crush down to a single point. Instead, all the strings that make up the matter and energy get tangled up in an unimaginably complex and dense ball. A fuzzball. This object doesn't have a singularity at its center. In fact, it has no empty space inside it at all. The fuzzball itself extends all the way out to what we would call the event horizon. So when you look at a black hole, you're not looking at a gateway to nothingness. You're looking at the fuzzy, vibrating, tangled surface of this gigantic ball of strings. So, let's go back to our journey one more time. What happens if you fall towards a fuzzball? You wouldn't pass through a calm, empty event horizon. As you approached, you would begin to interact with this fuzzy surface. Your own fundamental strings would get tangled up with the strings of the fuzzball. The information that makes you, the specific vibration of your strings, wouldn't be destroyed. It would be added to the fuzzball. Your song would become part of its symphony. Your thread would be woven into its cosmic tapestry. You would become one with the black hole itself. The fuzzball theory elegantly solves the information paradox. The information isn't lost because the fuzzball is a physical object that contains all the information of everything it has ever absorbed. It also means there's no singularity, so the laws of physics never break down. And it's a concrete example of the holographic principle we talked about. All the information about the three-dimensional things that fell in is stored on the two-dimensional surface of this fuzzball. The black hole is the hologram. Which do you find more comforting as a final destination? Becoming a permanent piece of information encoded in the subtle quantum hair of a traditional black hole, or having your fundamental essence woven into the beautiful, complex tangle of a cosmic fuzzball? It's a deeply philosophical question about what it means to be preserved. Drop a comment with your thoughts. I'm genuinely curious about how these different ideas feel to people. But the universe is clever, and it may have more than one way to solve a problem. There's another competing theory for what lies at the heart of a black hole, born from a rival to string theory called loop quantum gravity. This theory also gets rid of the singularity, but in a completely different and equally spectacular way. It suggests that at the center of a black hole, you don't find a point of infinite density or a fuzzball, but something called a Planck star. Loop quantum gravity views space-time itself as being made of tiny, indivisible quantum loops. There is a smallest possible size. You can't squeeze matter into a space smaller than this fundamental unit. So, as a star collapses, it gets denser and denser and denser, but it can never reach an infinite density because it can't be crushed into a point smaller than these fundamental loops of space. Instead, when the matter is compressed to this unbelievable density known as the Planck density, new force of nature takes over, a powerful repulsive force, born from the quantum nature of space-time itself, pushes back. It's like trying to squeeze a spring down to zero length. At some point, it just refuses to be compressed any further and pushes back with immense force. This quantum pressure halts the collapse completely. The matter doesn't form a singularity. It forms an ultra-compact object, no bigger than an atomic nucleus but containing the mass of a star. This is a Planck star. And then, something amazing happens. The collapsing matter bounces. It's a big bounce, but on a very small scale. But wait, if the matter just bounces back and explodes, why do we see a black hole that seems stable for billions of years? The answer is the most extreme time dilation imaginable. From the perspective of the collapsing matter, the bounce is almost instantaneous. But for us, watching from the outside, time near the center of the black hole is slowed down to an almost complete stop. A bounce that takes a fraction of a second for the matter itself could look like it takes billions or even trillions of years from our perspective. So, a black hole could be a star frozen in the middle of a bounce. It's a cosmic movie playing in the most extreme slow motion possible. Our journey into this black hole would be a journey toward this incredibly dense Planck star at its core. We would be falling toward a moment of cosmic rebirth, stretched out over eons. And what happens at the end? Eventually, after a very, very long time, the black hole evaporates through Hawking radiation. As it loses mass, its gravity weakens, and the time dilation effect gets less extreme. It's like the slow-motion dial is slowly being turned back towards normal speed. Eventually, the black hole gets small enough that the bounce can finally complete from our perspective. The Planck star explodes. And in that final explosion, it releases all the information that was trapped inside for all those billions of years. Once again, the information paradox is solved. The information wasn't deleted, it was just put in a cosmic prison with a very, very long sentence. But eventually, it gets paroled. The black hole is not a final destination, but a temporary holding cell, a place where matter and information wait in suspended animation before being reborn into the universe. So we have these incredible, poetic alternatives to the terrifying singularity. A black hole could be a bald object with subtle quantum hair. It could be a giant, tangled fuzzball of cosmic strings. Or it could be a star caught in a time-dilated bounce, waiting to explode at the end of time. All of these ideas are born from our best attempts to unite our two great theories of the universe's general relativity and quantum mechanics. The heart of a black hole is the place where these two theories meet, and the sparks from that collision light up our imagination with these beautiful possibilities. Each of these ideas paints a different picture of our universe and our place in it. Are we living in a universe of simple, bald objects that hide their secrets forever? Or A universe of complex, hairy objects that whisper their stories into the fabric of space. A universe of tangled tapestries? Or a universe of cosmic rebirths? The truth is still out there, waiting in the dark. We've journeyed from the edge of the event horizon to the very heart of these cosmic mysteries. We've explored what it might feel like to fall in, what we might see, and the different fates that might await us at the center. We've seen how these objects, which seem like pure destruction, are actually battlegrounds for the deepest principles of reality, and how they might even be engines of creation and rebirth. But now, it's time to pull back, to zoom out from our personal journey into a single black hole, and ask one final, epic question. What is the role of these strange objects in the grand story of the entire universe? They shape galaxies, they challenge our understanding of reality, but what is their ultimate purpose in the cosmic play? What part will they play in the final act of the universe itself? Of course. Let's take that final step together, zooming out from the heart of a single black hole to witness their role in the grand cosmic ballet from now until the very end of time. We've been on an intimate journey, you and I, falling through the dark. But now, I want you to float back out, past the event horizon, past the swirling disk of light, past the nearby stars, until our entire galaxy is just a beautiful, spiral-shaped jewel below us. From this vantage point, we can see the universe for what it is right now, a place of incredible fire and light. We live in what astronomers call the stelliferous Aurora era of stars. It's a brilliant, vibrant, and fleeting youth. The universe is filled with gas clouds collapsing to form new stars, and those stars are burning, fusing elements, creating light and life and all the things we know. Black holes exist, yes. They are the gravitational anchors of galaxies, the quiet monsters in the dark, but the stars are the main characters of this chapter. The universe is loud, bright, and full of action. But every fire, no matter how bright, eventually fades. Every story has a later chapter, and the universe's next chapter is a long, slow, and profoundly quiet one. Let's fast forward in time, far into the future. Trillions of years from now, all the gas will have been used up. No new stars can be born, and every existing star, from the smallest red dwarf to the most massive blue giant, will have exhausted its fuel and died. The lights will go out, one by one, across the cosmos. Our own sun will be a cold, dead chunk of crystal called a black dwarf. The universe will enter a new age, the degenerate era. Imagine this future. It's a realm of cosmic ghosts. The universe is now populated only by the corpses of stars, white dwarfs, neutron stars, and black hole sol floating silently in an expanding, ever colder darkness. The grand celestial dance is over. The planets will have been flung away from their dead stars, or will have spiraled into them. What's left is a graveyard, a vast, cold, and dark expanse of stellar remnants. But even in this age of ghosts, the universe is not static. An even slower, more fundamental process will begin to take hold. A theory in physics predicts something called proton decay. It suggests that the very building blocks of matter, the protons and neutrons that make up the atoms of everything you see, are not eternally stable. Over unimaginable timescales, something like 10 to the power of 40 years, they will decay, breaking down into simpler, lighter particles like photons and positrons. Think about what this means. Everything we consider solid, permanent matter will just dissolve, like a sugar cube in water, but on a timescale that makes the current age of the universe seem like less than a blink of an eye. The dead stars, the black dwarfs, the neutron stars, all the cosmic debris of our era, will slowly, atom by atom, evaporate into a thin, featureless mist of radiation. It's the ultimate erosion, the final victory of entropy over structure. After this process has completed, after the last atom has dissolved, what will be left? What objects are so robust, so gravitationally dominant, that they can survive the dissolution of matter itself? Only the black holes. They will be the sole inheritors of the universe. They are the only things that will survive the degenerate era. And so, we enter the next, and by far the longest, act in the cosmic drama, the black hole era. Let's try to picture it. The universe is now almost perfectly empty and dark. The cold remnants of stars have vanished. There is only a vast, cold, expanding void, populated by solitary black holes. The distance between them will be so immense that for all practical purposes, each black hole will be its own isolated universe. There will be nothing else. No light, no sound, no matter. Just these silent spinning spheres of warped space-time floating alone in the eternal night. They are the last bastions of complexity, the final monuments of a universe that was once filled with fire. For a period of time so long, it breaks our ability to even write the number in any meaningful way. This will be the state of reality. Nothing will happen, but nothing isn't quite right. One process will still be unfolding. One final, slow, cosmic action will be playing out. The process that Stephen Hawking discovered. The black holes themselves will be evaporating. This is the main event of the black hole era. The only event. That faint quantum glow of Hawking radiation will be the only light in the universe. Each black hole, from the smallest to the most gargantuan, will be slowly, patiently, losing mass, particle by particle, radiating its very being away into the void. It's the universe's final, long exhale. The timescales are staggering. A black hole with the mass of our sun will take around 10 to the power of 67 years to evaporate. But the supermassive black holes, the ones at the centers of galaxies that weigh billions of solar masses, they will last for an almost unbelievable length of time. Something on the order of 10 to the power of 100 years. This number is called a googol. It's a 1 with 100 zeros after it. There aren't that many particles in the entire observable universe. For a googol years, the universe will be nothing but these evaporating black holes. They will be the final actors on the cosmic stage, playing out their slow, solitary deaths. Now, let's journey to the very end. The end of the black hole era. Imagine the very last black hole in the entire universe. It's the biggest one, the one that has taken the longest to die. For a googol years, it has been shrinking, so slowly, so imperceptibly. As it gets smaller, the process of evaporation speeds up. In its final moments, it will no longer be a slow leak. It will become a blaze of energy, releasing all of its remaining mass in a final weak flash of light. Picture it. After an eternity of darkness, one last flash, and then nothing. The last black hole is gone. The last complex object in the universe has vanished, and we enter the final eternal age of the cosmos, the dark era, also known as the heat death of the universe. The universe is now a vast, endlessly expanding void of unimaginable size. It's filled with a thin, uniform, and ever-cooling soup of low-energy particles, photons, neutrinos, the last remnants of the evaporated black holes and decayed matter. There is no structure, no planets, no stars, no black holes. The temperature everywhere is almost absolute zero. Because everything is the same temperature, no work can be done. No information can be processed. No change can happen. The arrow of time itself becomes meaningless, because there are no events to distinguish one moment from the next. The cosmic story has come to an end. It's not a violent end in fire, but a peaceful, silent end in ice-cold darkness. It is the perfect, final equilibrium. And so, we see the ultimate role of the black hole. They are the great mediators of the universe's final act. They patiently gather up all the matter and complexity of the bright starlit era. They hold on to it, acting as cosmic time capsules through the long, dark twilight. And then, over a timescale that dwarfs all others, they slowly and carefully release it all back into the universe as simple, unstructured thermal energy, bringing the cosmos to its final, peaceful, and eternal rest. They are not just destroyers or prisons. They are the agents of the universe's ultimate transformation, the shepherds that guide reality to its inevitable, quiet conclusion. It's a humbling and perhaps a melancholy thought. But there's a final twist to this bedtime story, a glimmer of hope, depending on how you see it. Remember our journey through the spinning ring singularity? The idea that a black hole could be a gateway to a new universe, a new Big Bang? What if that's the true final purpose? What if, as our universe fades into a cold, dark void, the trillions of black holes it contained have each, in their own way, served as the seeds for new universes? Universes with their own stars, their own planets, and perhaps their own life, all born from the collapse of matter in our own. It suggests a cosmos that is not a single story with a beginning and an end, but an endless cosmic tree with new universes branching off from the old ones, forever and ever. Our universe's heat death might not be an end, but merely a transition, the final exhalation that gives life to countless children. We don't know, we may never know, but it's a beautiful thought to hold on to as we end our journey. We have traveled from the first moment of falling to the final moment of the cosmos itself. We've seen that black holes are not just objects. They are places where space and time break down, where information is challenged, where new realities might be born, and where the ultimate fate of our universe is written. Thank you for taking this journey with me tonight. The next time you look up at the night sky, maybe you'll see it a little differently. You're looking at the fleeting, brilliant youth of the universe. Appreciate this vibrant starlit moment we live in. It's a precious and temporary exception in the long, dark story of time. And in that darkness, remember the silent, patient black holes holding on to the memory of our era, and perhaps, just perhaps, holding the seeds of the next. What does this journey through all of space and time make you feel? Let me know one last time in the comments below. Sleep well and keep looking up.